Hi guys, I hope you guys have been having a fantastic days in Jay on the beach. It's been really a pleasure for us as organizers to really have you around, and hopefully that you're enjoying very much the conferences as much as we do. So, you will be surprised a little bit about this title, Big data makes me grumpy, as in like, so why is that? Why is it, well, and to be honest, you have to understand what I'm going to say. You have to get to know us a little bit better. So, who are we? We are first and foremost, we are a software company. What is it what we are all about? Or maybe we can explain it the other way around. I mean, what is it what we don't do? So we are not systems integrators. We are not a consultancy company. You cannot ask us to develop a bespoke solution for your company. We like to build products. We like to be innovators. We create software solutions for big, very, very large organizations to use. Just to give you a hint, out of the 10 biggest investment banks in the world, 9 are heavy clients of us. So when we talk about big data, we really mean it. We've been doing big data for many, many years. I mean, I had the pleasure of leading a team that was doing the first Lambda architecture 5 years earlier than Lambda architecture even existed in the marketplace. So we've been doing this thing for a very, very long time. So what are the kind of attributes that defines my teams? We are humble. What it means is that we really look at things in a humble way, in a humble perspective, and we are very hungry at the same time. We really think that innovation and being hungry is the driver for creating better products, better solutions, better value propositions for customers. And most certainly, and I think that if you have met any of my guys today, we do have a point of view, a very strong point of view. So we really we really enjoy having an opinion and defending that opinion throughout our products, development, careers, and so forth. So, therefore, what is it what we do? At the end of the day, we build solutions, and those solutions are based on software, and we really think that we're building the best solutions that we can possibly can. And how is that? How can we really say those things? It's like we're driven by by simplicity. For us, it's one of the best things that you can possibly do as a software engineering house is being driven by simple solutions, but not simpler. There is a big difference between naivety and simplicity. Therefore, usability really comes first for us. It's one of our key paramounts. As a matter of fact, my team here in Malaga has 3 usability experts, plus I got another person in a different development center. So we are very UX focused. And UX really starts from the moment that you land in my website, to the moment that you install my software, to the moment that you have to maintain my software or read my documentation. It's a whole experience. So what we do is like, as I said before, we have to build seriously resilient applications. We come from a monitoring background in my company. What it means is that we are actually the eyes, the ears, the senses that all clients use to understand what is happening in their business, from infrastructure level down to application level, from business processes to very simple batch processes they run overnight. The consequences of not having a good monitoring function implies most of our clients hefty fines on the marketplace by the regulators and so forth. So it's not something that we take very lightly. So resiliency comes really at first. And really, as a follow-up, a little bit of our core values in our team and so forth, we like, to be a continuous improvement type of shop. We are never satisfied. We always want to find something new. We always want to improve our stuff. Can we make it simpler? Can we make it more usable? Can it be made more resilient? It's a continuous improvement. So streaming data, streaming big data. So let's have a look at what an architecture today is going to look like. So you got your data sources, starting from syslog, ETW if you are in a Windows platform, SNMP just to communicate for a number of devices, log files, socket information that it comes on a streaming socket, market data information for many of our clients. It's really, really complex sources of information. So the first thing that you do is just to put agents in every single machine, which you need to configure, which you need to maintain. It's a heavy, heavy task. Just to give you an example, one of our clients has in between 20 to 25,000 servers being monitored. And each one of those servers produces between 5 to 20 real-time streams of data, point per second. That is a huge amount of data, huge amount of data points that you really need to control. So, from a cost perspective, it's quite a healthy team, a healthy investment, the one our clients have to do in that area. Then, now I got my agent, what is it what I'm going to be doing with my data? Then I need to distribute it, and then off you go and start finding, okay, I need Kafka, for example, or any AMPQ, for example, or a RabbitMQ, whatever methodology you happen to use for delivering your data to your middle tier. So, simple enough. First cluster in the picture, you want it to be scalable. It's its own technology, happens to run in their own grid, and if you're lucky, will be probably decentralized from a monitoring perspective. Otherwise, you need to put Zookeeper or something along those lines to keep it up and running. But simple. And now you want to process that data in real time. So you go and basically choose whatever options are there in the marketplace, from open source solutions like could be S4, Storm, Spark, if you don't mind about the micro-batching side of things. And it's a really complicated side of your architecture. Really, it's topology-driven. More often than not, it's configuration-driven. What it means is that changes in this layer are later on propagated back even down to the way you write algorithms, so it becomes rather complicated and critical part of your stack, really complex one. Yet again, runs on its own cluster, runs with their own policy services, with their own data abstractions, with their own semantics, quite complex to go through. Now, finally, you go, okay, now that I got all the streaming data, they're asking me for yesterday's data. I need to put a big data solution, as in like a Hadoop parallel file system. I need to put an elastic cluster, perhaps for doing all the indexing. Let's put Hive and Edgebase to make things easier, or I might go private, as in like buy a product like Vertica, Sybase, IQ, and so forth. Really starts the complicated stuff happens here. But pay attention to something. The way we treat data in the real time now is completely different to the way that we model data in the storage system. So hence now you have two paradigms to access data. That already for when you put the final layer on, which is your analytical tools, your UI, your web access, your scriptability layer, your Dockers, your sysadmin side of things. Wow. This is a very healthy problem to have. So imagine as a software vendors, if we go to perhaps not first-tier banks, but second-tier banks and third-tier banks, which we happen to have quite a few of those clients, and say like, hey, I just built this fantastic solution for you, but you need about 50 people to maintain it. They go like, and you know what? This is what happens. The angry cat comes in there into the room, and he goes like, I don't think this is going to happen, So software vendors, can we do it better? Where is our innovation? So the grumpy cat, the grumpy cat start asking the question, say, hey, even if I was to accept that picture that you just gave me, what happened with security? I got 5 different clusters in this picture, each with own security model, with their own entitlement system, with no guarantees of encryptability on disk or intermediate storage and so forth. I'm storing customers' data. How many times have you heard, hey, credit cards have been stolen from one place? Hello, we are in the 21st century. Surely we can do things better than that. Auditability. Fred has changed something yesterday because they put a new release. Nobody knew about it. Everything is broken afterwards. Complex system requires from audit tools, very, very important. Monitor it. Is it running? Is it not? I haven't received that message that I'm supposed to have it received. what's going on? I got 5 different layers in which I'm getting lost more often than not. Are we getting the best performance? Yes. And if we do, how do we know? It's so complex that you need really an expert in queue modeling in order to make sense of all of it. Then, which data abstractions I end up working with as a user of this system? What is the APIs that I end up programming with? I got some, but they change whether they're coming down from a storage system, if I'm using a database or a Cassandra or a Spark, the data happens to be modeled different. So therefore, how can I write new algorithms for my platform? Or most importantly, once I have written those algorithms, how on earth am I going to guarantee if any pieces of my stack is changing, I'm not going to get impacted? So really, if you think about it, it's a big shopping list that at the end of the day takes you back to the drawing board and say like, hello, we can do it better. Can we do it simpler? Can we put usability at first? Can it be resilient? And can it be a platform whereby we can have a continuous improvement? So Grumpy Cat, shopping list. So I want a streaming system. No batches, no micro batches. Data comes through, analytics comes out. Very simple stuff, but very complicated in reality. Then I want stream semantics. This is what I do, streaming big data. So I want a CEP engine. I want to have semantics for moving windows. I want to have distributed joins. I want to have aggregations. I want to do quite a fair amount of stuff with the data that it comes. So we follow up with a strong data-centric solution. I want a rich type system, please. We have passed beyond the simple double and strings or integers. Can I have a type for an email that I can run operations on? Can I have a type to model IP addresses, geo information, latitude, longitude, geo-hashing? Can I represent that information in my data model? Then can I have multiple data formats? Can I ingress data in CSV format? And can I request the data out in JSON? Why am I always subject to a specific data representation? And most importantly, I really want my data to be immutable. At the end of the day, the facts that I'm grabbing coming from a real-time stream are the truth about my business right now. So I don't want anyone to mess around with my truth. I don't want to have a system where Fred can come about and just change my data without me knowing. So it's super important. Being immutability in data will resolve a fair amount of problems later on. So I want one cluster, not 5, just one. Simplicity really comes first. So what are the attributes of that cluster? So it has to be decentralized, has to be symmetric. By symmetric, I mean that every single node performs the same function. I don't have nominated single points of failure. It has to grow organically. I wanted, therefore, incremental scalability. The more nodes I add, the more I get. Heterogeneous, I got Windows machine, I got Linux machines, I got an IEX machine. More often than not, you will be surprised that those machines are still alive and kicking. I got a Solaris machine and so forth. Can I not use them? Why am I subject to a specific platform? I really want it to be heterogeneous. I want the cluster to take care of partition and replication of data for fault-tolerant perspective, because really, you need to embrace failure. Things will go wrong at some point, and you really have to program and code for those. Certainly, administration-friendly goes without saying. So what Grumpy Cat says even more is that I want the system to be open, because I want it to integrate it with my existing stuff. I'm not going to be the solution for all problems in the world, therefore I need to play ball with the rest of the systems in my organization. So I wanted an open REST architecture with strong APIs, so I can program it, so I can deal with it in a nice way. I want it to be machine learning friendly. This is where the pressure is going from my algorithm teams. Therefore, I want to integrate with tools like R, MATLAB, Python, and so forth, and really write those algorithms only once. Therefore, they cannot be topology driven, either directly or indirectly, as you will get with a Spark or a Storm or S4. Finally, I want it to be secure and auditable. Again, we live in the 21st century. There is something beautiful out there called elliptic cryptography, which is cheap on the CPU, runs on mobile devices, gives you RSA 3000 bit strength, and really is beautiful. So let's use it, please. Then I want my data encrypted on disk and so forth. So, when Grumpy Cat finished with this shopping list, this is what happened with my engineering team. They went like, what? You must be kidding now. But you know what? 2 years ago, we started this project. I'm actually 18, even though I look like 40. That is all to do with the last 2 years and a half of very hard work. We did it. Well, at least we think we did it in a more humble way. So, we word of attempt. If you try to do this, think twice. This is hard. This is seriously hard, yeah? So we only been able to do it because I have the luxury of having an amazing team. I'm surrounded by people that has a combined experience of more than 50 years in developing real-time systems. So this is not new to us. This is something that we have grown through for the last 10 years individually, delivering systems in a very demanding environment like hedge funds or investment banks. But listen, if you still are crazy enough, talk to me. I'd like to talk to you because we are always open to hire new talent. Therefore, you are very much welcome to come. So, what is Velo? So, all that shopping list, what it really boils down into. Velo is a Dynamo-like cluster. So it's very much inspired by the principles that run Dynamo. I don't know if you know Dynamo. Hands up if anybody knows Dynamo. Quite flexible architecture is the one that when you store stuff in S3 in Amazon is the system that drives that. Is when you do a shopping cart in Amazon, this is what is taking your trolley with you. And then in case there is failures and so forth, your trolley is still there. Very sound architecture, proven for many years. Most importantly, decentralized. No single point of failure, no zookeeper, no mesos, no administration out there. Super simple stuff and really works like, by gossiping the state of the cluster amongst themselves. I can explain that thing later if you guys want me to. So, not just real time, every single node in that cluster is incorporating built-in repositories. So we have repositories for storing metrics, time series data. This is something that we have built from scratch because we couldn't find anything on the marketplace that we could use. Columnar store, bitmap indices with shared memory in their approach to data. So very efficient, extremely fast way of accessing your time series data. We have a second repository, which is to do with events. It's built on Lucene. Awesome technology. If you are not using it, you certainly should have a look to it. What we also do is we obviously expose a rich API, as we were saying before, and a very complex data sets. We are polyglot. We take REST seriously. Therefore, you can send us any form of payload. We will understand it. You can ask the responses in any type of format. As long as it's representable, we can send it back. So we have a pure representational state transfer system. It's not just HTTP. And really, for once, what we have managed to achieve is unify, very simply, your pipeline processing for real-time data to just change a single keyword, and you will run it on your historical repositories. So it's very cool technology from that perspective. So do you guys want to see it? Okay, let's do that. So, as always with live demos, what it can go wrong? Let's see. Okay, so let's get Velo up and running. So I'm just going to run a single node. Velo is more than enough for a presentation. Velo is, by the way, is built on using Scala and Akka, if you were wondering. So I'm picking a process that streams data through this simulated data. And I'm going to keep this demonstration very simple. Just if you guys really want to know more about this thing, just grab any of the guys with this T-shirt, and we will be delighted to show you out. So I'm going to use a program that we built. It's called ITRS Insights. It's a workbench to interact with the system, and allows you to run things like notebooks and the like. So resolution is not at its best, so it will be a little bit difficult to see. So shall we say I got a streaming data here coming from, simulated from an Apache server. So we can just query the data as it happens to arrive, as simple as doing this. So as you can see, we are receiving information, has the contributor, has the size of the payload, has the domain of the client, the host, the resources that is being accessed. So what are my, heavy hitters here? What are the people that are using more my server? Typical question that you will do in many different. So how you go about is as simple as just following up with this type of SQL language, and you go like select top K, let's say 10, and let's say resources. I think it's resource, yeah. And then shall we measure by counts or shall we measure by bandwidth utilization? Let's do counts first. Okay. And then select OK, resource 1. There you are. That's your top K, your busiest pages on your website. Very simple. You have 6% is going to the root page, then about 3.8% is going to that page over there, and so forth. Super simple stuff. Over real-time streaming with no sweat. So if you want to, let's say, right, but just give me more. Just tell me what each one of my clients are doing, okay? Group by host. Host. There you go. So now you have an analysis of what are on every single client that you have, which are the resources that the top 10 resources that guy is using the most. Shall we do it by bandwidth? Easy. Let's do that. So instead of incremented by 1 every time that we see somebody, let's increment it by the size of the response. There you are. So now I'm basically measuring what are the biggest hitters in my network utilization right now. As you can see, very simple stuff. Again, simplicity comes at its first. This SQLite language is the first language that we have produced to interact with the system. We have an Scala DSL where you can write the same queries from a more programmatic experience, and we will be launching a Python API very soon. So the question is, what you meant about having a unified storage and a streaming system? Well, have a look at this. If I wanted to run this very same analysis from the data that I'm currently storing on disk, this is what I need to do. Single unified model that is across your entire database, your top K analysis done in less than a second in a notebook. So very simple stuff. Again, simplicity, improvement, scalability, one cluster, unified data model, really a good technology to go forward. So I will be delighted if you, I don't want to extend the presentation. I'm not sure how we're doing in terms of time, but 10, awesome. So if you guys want to know more about this, please grab me or grab Tobias or whomever else. We will be delighted to show you around. So we just try to finish the presentation. So is Bailo finished? Well, remember, continuous improvement? Of course not. We always find things better to do. So what is it what we're doing right now? We are heavily focusing on ML algorithms at the moment. We are writing OpenCL code heavily to have the batching part of, TSNE for dimensionality reduction, for visualization in a high dimensional space. We're finishing PCA at the moment on OpenCL. We are doing quite a fair amount of work on clustering analysis of time series which is quite novel. It's based on a paper that appeared on the academia just about 6 months ago. So we are now basically building up the set of functions that you can use with Velo. We are adding an ODBC, JDBC driver, so you can integrate Velo very nicely with your Office, with your Tableau, with your favorite visualizations out there to create reports and so forth. We have an early version of Python integration. We still need to work on R a little bit more. This is something that we parked in a branch, and even though we were delighted to go that, we had to deviate our pressures to somewhere else, so we need to rescue it a little bit and get it out. We need to formally publish the SDKs. At the moment, the documentation that you will find in Velo.io is the one that describes the REST interface, but there are more SDKs. There are SDKs for writing your own transport system. There are SDKs for writing your own algorithms. There are plenty of things there that you can use. And finally, 50% of the work that we do is what I just showed you. You can have the best data analytics in the world, but if you don't have a very strong data acquisition system, then you are halfway through. So we are not talking today about this thing, but Marcos, I believe, is over there. He can explain you all about the work that we're doing in terms of data acquisition. Is awesome, I have to say. This is something that I'm very proud of, the work that we're doing down there. So please ask us if you guys want to know a little bit more about this layer that we're adding. So with this, I'm concluding the presentation today. I hope I gave you a good introduction to what Velo is all about, or motivations for building a system like this. And I'm at your disposal for any questions that you might have. Thank you.
Justo, could you tell us where we could get more information online?
Surely. I mean, there is a website called Velo.io, whereby you will find all the documentation associated with the product. There is even a download that you can take home and just play with the product. And if there are email contact addresses there, in case you guys want to reach us out for any doubts, questions, or whatever, obviously we are at your disposal. We are based, mainly the Velo team is based in Malaga, but it's very distributed. I got two guys working in Sydney, about 3 guys working in London. The rest of the team is down here, and I'm all over the place. I'm constantly in between London, Hong Kong, New York, and here in Malaga, so I hardly can say where you guys are going to find me. Any other questions? Fantastic. All right. Thank you so much. Thank you. That we're building the best solutions that we can possibly can. And how is that? How can we really say those things? It's like we're driven by by simplicity. For us, it's one of the best things that you can possibly do as a software engineering house is being driven by simple solutions, but not simpler. There is a big difference between naivety and simplicity. Therefore, usability really comes first for us. It's one of our key paramounts. As a matter of fact, my team here in Malaga has 3 usability experts, plus I got another person in a different development center. Hi guys, I hope you guys have been having a fantastic days in Jay on the Beach. It's been really a pleasure for us as organizers to really have you around, and hoping that you're enjoying very much the conferences as much as we do. So, you will be surprised a little bit about this title. Big data makes me grumpy, as in like, so why is that? Why is it? Well, and to be honest, you have to understand what I'm going to say. You have to get to know us a little bit better. So, 10 biggest investment banks in the world, 9 are heavy clients of us. So when we talk about big data, we really mean it. we've been doing big data for many, many years. I mean, I had the pleasure of leading a team that was doing the first Lambda architecture 5 years earlier than Lambda architecture that even existed in the marketplace. So we've been doing this thing for a very, very long time. So what are the kind of attributes that defines my teams? You know, we are humble. What it means is that we really look at things in a humble way, in a humble perspective, and we are very hungry at the same time. We really think that innovation and being hungry is the driver for creating better products, better solutions, better value propositions for customers. And most certainly, and I think that if you have met any of my guys today, we do have a point of view, a very strong one point of view. So we really we really enjoy having an opinion and defending that opinion throughout our products, development, careers, and so forth. So, you know, therefore, what is it what we do? At the end of the day, we build solutions, and those solutions are based on software, and we really think, who are we? We are first and foremost, we are a software company. What is it what we are all about? Or maybe we can explain it the other way around. I mean, what is it what we don't do? So we are not systems integrators. We are not a consultancy company. You cannot ask us to develop a bespoke solution for your company. We like to build products. We like to be innovators. We create software solutions for big, very, very large organizations to use. Just to give you a hint, out of the